Well, it isn't quite as sunny as it was yesterday. Anyway, I thought I'd quickly show you the generators working, but one thing I didn't mention yesterday, the alarm panel, the fire alarm panel, is also connected to the gate, and since I built the controller for the gate and wrote the software to run it, it's all inside that box there. There's quite a bit of stuff in there. You'd be surprised how much, well, you probably won't be surprised at how much stuff I put in that box to just control a simple gate. But anyway, that's for another day. So when the alarm panel is active, the security company will call the fire brigade for me, and when they get here the gate will be open, because the gate has a fire service mode that I wrote as part of the software. So the alarm panel can override everything, and it just opens the gate and holds it open till it's reset, basically. So the fire service come in and they walk up here and up the steps, and when they get to the front door, if I'm not home, they look at the front door and they see that. And key 197 is a master key that the fire service use. All their crews have the key on them, and it's used for getting into all the commercial properties that they look after. So I had a locksmith dual key the barrel on that lock, so I have just a normal key that I use to unlock that door. But if the fire service need to get into the house, that tells them that their master key will let them in. So in they go, have a look around, do what they need to do. Heaven forbid there's an actual fire they need to put out. Hello cat, are you going to come out and be nosy again? Come here, friendly, puss 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 puss. Come here. No, I think he's content out there. Anyway, so that's how the alarm panel works and the fire service get access. So we'll start with the big generator first. So if there's, as I was saying yesterday, if there's low voltage or high voltage or no voltage at all, that regulator will start the generator. And I won't get into the specifics of how it starts the generator, except to say that I also installed the controller and the automation on the generator. It was just a standard key start generator, so I wired up a controller and wrote all the software to make it work the way I want it to. So to actually do a test run of it, this circuit breaker here is the feed into that. So to make that think that there's a power cut, all I do is kill the mains feed to it, like that. And the generator is now thinking the power's off, and will wait for 10 seconds before doing anything, and then it will start. And it does not like being woken up on cold wet days like this, but it will get there eventually. Unfortunately, this is what most generators will do. They sit around for months doing nothing at all, and then they have to run. So it's idling now just to make itself happy, and then it'll rev up and plug itself in once it sees good oil pressure and everything else is okay. Is now running the house. So the whole house is now on the generator, which is easily proven. If we hop back inside, what we'll see is that there's now a light on this relay. So that relay is what the generator uses to switch between these two contactors. That one's the mains from the street, that one's the generator. So that one is the one that's now on, and the whole house is now disconnected from the mains. So that includes the server room, that includes the whole house. All of this is all now running off that generator. So if there was no power from the street, it wouldn't make any difference, everything would be running. And the emergency light system isn't on because the house has power. The emergency panel, emergency lighting only comes on when there's no power at all coming into the house. So then to tell a generator that the power cut is over, just reconnect the power supply to there, and the generator will wait for 10 seconds and then disconnect. There we go. So the house is now back on the mains and the generator is now idling, and it will sit out there idling for 5 minutes just in case the power goes off again. It's already running, so it just revs up and plugs itself back in. But after 5 minutes, if the power is still on, it'll shut itself down and go back to standby. So there we go, there it is, idling. If the power goes off while it's still idling, it just revs up and plugs back in. And after 5 minutes, it just shuts itself down and goes back into sleep mode. The shed was built sort of not completed, but I was going to fully enclose it and try and muffle the sound a little bit, because obviously at 3 o'clock in the morning this is a little bit annoying for me and for the neighbours, having a generator roaring away like this. But once I build the car shed here, I'll put this generator and the other generator inside it, and then I'll quieten them up as much as I can once they're in a proper building. So the shed got half built, and then I realised the generator was in completely the wrong place, so I never got any further. The baby generator is only big enough to run the server room. It's a 16 amp single phase generator, so it can run all this stuff and the air conditioner and the emergency lighting, and there's still a bit of spare capacity, but that's all I'm using the baby generator for. The main generator is a 3-phase 32 amp per phase genset, so it's 96 amps in total. It can go a little bit higher, but it's fused at 32 amps per phase. So anyway, the baby generator is for running the server room. So that generator is a backup power supply for the mains when it goes down, and this generator is a backup power supply for that generator if it doesn't run and the mains are off. So I've got a backup generator for a backup generator, which is what this is. And this one's a little bit quicker. It only takes 7 seconds between the power going off and it actually plugging itself in and powering things, and that's because it is a very small generator, and its main purpose is to get the power on as quickly as possible. It doesn't muck around. So slightly different setup. These breakers here are the feeds into this room from the generator. I think it's servers, air conditioner, emergency lighting, and a few other little bits and bobs, but I won't get into what those are. This is not on the same feed as these ones. Those two are waiting there to be used for something else, and these are the contactors for the generator to plug itself in. So at the moment the mains are plugged in, and then the other contactor will go down when the generator wants to plug itself in, and that relay is what the generator uses to switch them between each other. So once again, all I need to do is make the generator think the power's gone off by killing the power supply to it, and this will happen very quickly. Or maybe it won't. This is why you need to test these things regularly. So okay, something has gone terribly wrong. That generator should have come into life. Well, this is the panel for the baby generator, and the reason it didn't start is because the trickle charger, this thing that keeps the starter battery topped up, isn't working. It looks like one of these fuses is blown, so I'll have to pull that out and put a new fuse in. First, get a new fuse. That's the trickle charger for the two car batteries that run the automation. This generator is about 30 years old, and I didn't do the automation in it. It was done by a company in Auckland. Anyway, so there's the one of the panels. This is the controller that runs it. So there you go. There's the actual computer that runs it. The new modern equivalent is about an eighth of that size, and that's what I've used on the generator, and the same controller to run the gate. And they're sort of in the palm of your hand. They're just tiny little things. So anyway, it's now starting to rain. Joy, joy, fun, fun. And I'm going to be out here trying to find a blown fuse on an electrical panel in the rain. Okay, here we are back. I've just gone for a walk to the local electrical wholesaler and got myself a replacement fuse, which is that. The fuse that came out of there is 6 amp, and I'm replacing it with a 10 amp fuse because what I think has happened is that you can see that the trickle charges are different. This is the original one, it's 30 years old, and there was an identical one here. That's a 24 volt circuit for two car batteries in series to run the automation. This was a 12 volt trickle charger just to keep the starter battery charged. And the reason these are here is because standby generators like this will spend months and months sitting around doing nothing until one day the power goes off, and then they have to run. Normally a motor like this would charge up its own battery every day it runs, but because this sits here for months doing nothing, to keep the batteries charged, you need trickle chargers running them constantly, just keeping them topped up for when they do actually need to be used. So the computer in there uses these contactors and bits and pieces here to monitor that incoming mains voltage, and when the mains voltage disappears, that's how the generator knows the power's gone off, and then it starts up and does its job. And that same mains feed is what runs these two. The original one blew up about 3 years ago, and so I took it out and replaced it with this thing, which is the modern 30-year later equivalent, and I found it on Trade Me for about $40, I think. So it's just gone in place of this one. But what I think has happened is that this charger, despite being so much smaller than this one, has been drawing slightly more current than what the 6 amp fuse can handle, because it was originally a 6 amp fuse for one of these things. So if this has been drawing more current than 6 amps, that's why that has blown. So that's why I've replaced it with a 10 amp fuse in the hope that it'll get around that problem. So now all I need to do is turn the mains feed back on in the house and let the trickle charger sit there and charge the battery for a couple of hours, and then I'll come back and give this another try, and it should work, because I've metered the the starter battery, which is down here in the corner. I'm not going to open up that side of the generator, I don't really need to get in there, but you can see it there. There's the starter battery just in there, and there's the end of this end panel on the cabinet opens up and you can get in there. So I'll go and turn the power back on and be back in about 2 hours to try. Well, it's now about 5 o'clock in the evening. The trickle charger that I put in 3 years ago is now out and replaced with another one. This one hopefully is going to be a little bit more reliable. I've just gone to the local auto shop, and it's an automatic trickle charger, so it should be perfectly happy to be left there permanently on. So I've just spent the last 20 minutes messing around outside in an electrical cabinet in the rain. But it's not all bad. Some of the time I've spent in the mud on my ass. We'll leave it here and let it charge the battery for a couple of hours, and then I'll give the thing a try, and it should all work. And there we are, everything's all closed up. It's actually a lot darker than what it looks on the camera, but the charge has now been recharging the starter battery for about half an hour, so it should have enough charge in it to do something now. Let's just try starting it locally and seeing what happens. There we go. Okay, so after the fiasco of the whole afternoon, new trickle charger and a partly recharged starter battery, let's try this again. So you just saw that I can start it locally out there just by pressing the start button, but it's fully automatic, so when the power goes off it starts itself. And so once again, all I need to do to make it think the power has gone off is to kill the power feed to it, like that. And there we go. That is how it's supposed to work. Now the server room is running on that small generator, and then when the power comes back on, it just unplugs itself. There you go. So now we'll switch back over to mains. So the generator will run for another 5 minutes, just in case the power goes off again, and if it does, it just plugs itself back in immediately because it's already running. So there you go, now we're back on the generator. So then do that, and we're now back on the mains. So they both start when the power goes off. This one only takes 7 seconds from the power going off to it being up and running and having plugged itself in. The big one takes about a minute, maybe even 2 minutes, sitting out there coughing and spluttering to get itself going. But what should happen is they both run, and then once this one sees that the other generator is running, it shuts itself down. And it'll only keep going if the server room has no power, because the power's off from the street and because the other generator hasn't started. So it'll still be running, you can hear it in the background. And there we go, you can tell it's still running, and it'll just shut itself down in about 5 minutes. There's also a bit of a story about that generator. You remember you went into More FM with me on Simon Street, and we sat in their production studio and you recorded a few things for me in the voice booth. Just across the road from that building that More FM was in, Just a little bit further down Simon Street was where 89 FM was, and anyone from Auckland in the late 80s, early 90s will remember 89 FM and the top marks and all of that stuff. Well, when Radio New Zealand bought 89 FM in the late 80s, they eventually moved the station down to their main building a bit further down, closer to the central city, and they left a whole bunch of stuff there, including their emergency generator, which is now outside on my lawn. And the old 89 FM studios is the building that the Polytech that Matt and I met each other at ended up in, because they were abandoned, perfectly good studios, so it suited them for doing a audio engineering qualification course, which is what Matt and I were doing. And so I already knew the generator was still there, and the Polytech didn't know it was there and they weren't using it. And since Radio New Zealand couldn't care less about it, I gave the local rugby team some beers. We went down with a van and a trailer one weekend and brought it back. So that's the story of where I got the baby generator from. The big one I actually bought brand new, and it cost me about $11,000 9 years ago, and then I automated it. And for the automation and everything, it would have probably, if you had to pay somebody to do that to a generator, you'd be talking probably $5,000. So it's probably a $16,000 generator sitting out there, plus whatever the little baby one here is worth. Considering the baby one is worth, the baby one is 30 years old. It's probably not worth much, but the generator itself is still fine. It's a Lister Petter 2-cylinder generator, and it's done very, very low hours because it's only a mains backup generator, and generally they don't run very much, only when the power's off. So in 30 years the time switch, the time clock on it, it's showing less than 80 hours over 30 years. So that gives you an idea of how little that generator has actually run. So about the only thing that will blow up on it will be the controller, the actual computer that runs it, and when that happens I'll just replace it with another one and reprogram it all and get it all going again. Anyhow, there you go. That's just a little bit more of my house I thought you might be interested in seeing. I wasn't expecting quite the adventure of what it turned out to be this afternoon with the little baby generator, but never mind.